Whoa, that is so blurry. Okay, I'm back. How's everyone feeling today? Happy Friday, week 7 almost done. Happy April Fool's Day. Don't know, what else? How is everyone going? Let me know in the chat. Are you happy to be at week 7? No assignment? How cold is it today? I'm wearing a jumper for the first time in about 7 months. Although I've been very, very warm in this jumper, but now I don't want to take it off because I feel like I've committed to the jumper. The jumper has to stay. It is lecture 12. I know, cannot believe it. Friday afternoon, as usual, the best time for a lecture, especially on April the 1st. I see a few people are not sure what's going on. Yep, okay. Okay, how is everyone feeling about more linked lists? Because that's, I mean, yeah, you're getting more linked lists despite how you're feeling about them. So I hope you're feeling just a little bit of fondness for them now, maybe just a little tiny bit. So today is Tommy and Tammy in the chat. We'll be answering your questions, so feel free to pop all your questions in there. And yep, Tammy's not with us today, but Tommy is in the room with me, so that's exciting. Awesome, look at this. Questions have started. Can you point to a struct's memory address the same way you can point to a regular variable? Yes, indeed. Because a struct is a regular variable, it is just of type struct, and it might be a structure of a few things in there. So yeah, you absolutely can. What a great question. All right, let's have a look. So on Tuesday, I keep thinking today is, I don't know, whatever day, it feels like every day is the same day. So on Tuesday, we talked about linked lists. We created a list by inserting at the head of the list. Then someone said, why don't we insert at the tail? And I was like, yeah, let's do it. And then when I started drawing it, I realized we can't do it without doing something else first because we have to traverse the list. So guess what we're doing today? Today, we're traversing a list and we're inserting at the tail of the list. And we're also going to maybe hopefully have time to search for some conditions. And I'm going to rehash what we've done as well. So don't worry, I want to set the pace of you being able to understand what I'm saying, because if you understand, if you understand linked lists when we start here at the very beginning, it makes it a lot easier as we go on. So you might have noticed as well that haven't released assignment 2 yet. I'm sort of playing around with the idea of giving you a little bit more time to just, breathe and just have a little bit more of a break between assignments. And it's not going to have much of an impact on what's going on. Okay, so we're going to do a lot more linked lists. Just as I said, when is assignment 2 dropping? So it's going to drop soon, but I'm contemplating whether or not to give you one extra evening. A Friday night, can go wild, sleep the whole night, and then we can move on from there. All right, lecture code is here. So Tommy or Tammy will paste it into the chat. And we're really using sort of the same file that I started using from before as well, from Tuesday. Every day is the same. I wish these lectures were not so far spread out. Sleep, what's that? Oh gosh, please sleep. Sleep is very important. All right, quick rehash. And a lot of people on the feedback basically said, okay, so are we going to need to understand multi-file project for assignment 2? Okay, so what we've done is I decided linked lists are more important, okay? So I've moved multi-files and you can do the first 3 stages of the assignment without knowing anything about multi-file projects, okay? So we've changed it so that you don't have to, so that you're actually more focused on a linked list as opposed to anything else. Yeah. So, no, we're not doing double linked lists. No, calm down. No. Single is enough for now. One direction. No, I'm not going to. No, that's okay. I got nothing. Okay, so let's just quickly rehash. I know a lot of people in the feedback said, and thank you so much for leaving feedback. It was really lovely to see, because it's important for me to understand whether we're setting an okay pace, especially that I want you to really understand what's going on. So 23 parts each. No, my goodness, definitely not 23 parts each. 22, please calm down. No. So I'm gonna rehash linked lists a little bit. I know that I know that a few of you have said you understood the drawing, but it's the code aspect that you're having a little bit of trouble with. So we're gonna go over both of them again. Don't worry. And I'll poll you again throughout the lecture so that we know whether to stop and kind of solidify something, or we can move on from something, and so on and so forth. So don't worry, we will kind of return back to the basic and try and do it again and again. Okay, so I see Tom said in the chat that the assignment's nice. We promise that is not an April Fool's joke. Yeah, stage 1 and stage 2 I think are easier than in the past. I really want you to understand, I really want you to get familiar with linked lists and do that in a kind of like a more comfortable environment, because I think, linked lists are important, and, ease into it, ease into the, scavenger hunt. Okay, so let's do it. So a linked list, if you remember, and even if you don't, you're about to be reminded, is a list made up of many nodes, okay? And so we propose that one node is going to be a struct variable made up of some data and then a pointer to the next node. So then what it has in it is the address of the next node. And the way that they are linked together is only the previous node knows the address of the next one, and so on and so forth. So if you need to find anything in the list, you need to start at the very first node, and you need to visit each node until you get to whatever it is that you need to find. You can't just access any node of the list, or because you don't actually even know what nodes there are or how many nodes there are, because it's a dynamically sort of made structure, which means that you create each node as you need it. You don't create it at compile time, and you delete each node when you stop needing it. So you don't really, it's all good. You just kind of move on. So it's a dynamically allocated thing. You create each node as you need it, you get rid of it as you don't need it anymore, and then you link them up in a forward direction because it's a singular linked list, and only the previous one knows the address of the next one, and so on and so forth. So that's a great question. Does a node know the address of the previous node? Not in a singularly directed list, okay? You can have a list which would be linked in a double direction, which will also go the opposite way as well, but we're moving in one direction from start to the finish, so we're linked in a single direction here. And we're not going to do in this course more than just a single direction, so don't, but you can have definitely links in both directions going. Okay, so for example, a list with 135, which I think is one of the ones I drew for you with my beautiful drawing skills, is got basically things in the data of each node, and then the address of the next thing, an item in the data of 3, and then a link to the next one, an item, the last one. And then your last node will only point ever to null. So it's going to point to nothing because there's nothing that comes after it. So already maybe you can see how we can, pulse through and get to the end of the list, because we know we've gotten to the end of the list when we are at null, when there's nothing left. And if you remember from Tuesday, to start at the first node, we need to know the address of the first node. And we often call that the head of the list as a terminology. It doesn't matter. You can call it first node. It doesn't really matter. But head is just a consistent, it's just a name that is sort of consistently used across different places to have the address of the first node of the list. So the head is just a variable pointer, okay? And it's a pointer because what it stores inside it is the address of the first node. So in this case, the address of the first node is this, and that's what is stored in the pointer. So when I access the head, what I get is I can actually dereference it to get the data point. I can actually understand what's inside my first node, so I know where to start. So I'll know where to start because I keep track of where that first node is with the head, and then each node will have the address of the next one, and my last node will always point to a null pointer, which means that there is nothing else following it, and that's how I know that I've reached the end of the list. Okay, so how do you think I can move through the list to start at the head and then move to each subsequent node until we get to the end of the list? What do you reckon? What do you reckon? Would I move the head around? How would I get through it? What do you reckon? What are your thoughts? If it's possible to have thoughts at 3 o'clock in the afternoon on a Friday, what would your thoughts be of how you can move across the list? Yep, 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 yep. So definitely while loop. I love it. And if you are saying someone has hit it, make another pointer. Yep. Oh, fantastic. Well done. Well done. Okay, so while loop for sure. You see, you just can't run away from while loops. And I could, just so many bad jokes that you can make about while loops. Anyway, no. Okay, so you're right. So I can't really move my head over and over because then I'll lose track of where on earth my first node is, okay? So usually I'll have another pointer that I'll position at the head of the list. And usually that pointer, surprise, surprise, is called a current pointer. Not always. Again, you can call it whatever you want, okay? But it kind of just makes sense to call it that's where I am currently. So I'm going to create a current pointer. So again, it's going to be of type struct node pointer. So that means it's a pointer to a node. I'm going to call it current as the variable name, and I'm going to set it to the address that's inside this head. Okay. What this means is that I am pointing to the first node. Bless you, Tommy. He just sneezed and he tried to do it really quietly. I don't know if you heard, but it was very painful to watch. Okay, so that means that my current, if I've set it to the head, that means my current is now sitting on the first node, okay? And what that means is the head is not changing. So that means that I know that, I can always find the top of my list again if I need to. But the current node is the one that I'm going to keep changing because I don't really care what it is, so I can just keep going. Okay, so let's, then I saw that how would I move this current along to the next one? How would I be able to move it to the next node over here? So current is currently over here. How do I make it go over to this node over here, to the one with the 3? What do we reckon? I realize there's a delay, but the silence is deafening. 10-second delay. Okay. Yeah, well done. Change it to the address of the next node. Yeah. How do I get to the next node? What do we reckon? Okay, someone said current plus plus. I wish it was that easy. You're right. We are increasing the current, but how do we go to the next node? Oh gosh, no. Look at this. I'm going to blow your... Yes. Quite a few people are getting it now. Yes, that's right. So I have to point the current to the next. So if I access the next element of my current, okay, so if I go current and then I access inside the pointer, I dereference it and access the address of the next one, that will give me the address of the next node, okay? So what this means, if I do something like this, current is equal to current next, what will happen is my current will go into this next address and move itself over to here. So that means it will move into my second node. Okay, yeah, so we stab and we move it to the next. And don't worry, we're going to do the code for it and also draw another diagram. But someone requested I draw some better diagrams in my lecture notes, so I've tried to do really neat diagrams here. You need a detective. You just need a pointer. That's what you need. Yeah, so to do the way, we were doing, I++, and that was moving through an array, that was incrementing the array by 1. To increment a linked list by 1, we move current to current next, okay? Because if you remember, my struct had the next address. It was a struct pointer. No, it was my pointer was called next. So by saying current next, I'm actually going inside the next address, going in here. And if I go again, then I'll move it in here, and then I'll move on to the next one. Yeah. Okay, so then we move it again. Okay, so we go again, current is equal to current next, and we know that if we're doing anything multiple times, usually we're doing it in a while loop, and that's exactly what we'll be doing in a second, a while loop. So we're going to move it again. So once we go current is equal to current next, we're going to move it again up from 1. Yeah, that's right, Jeffrey, that's it. So linked lists are not, they're just random addresses from random places in memory, which is why we can't just do, current plus plus. The way it's not just increasing my counter by 1 and then moving the index as in an array, because they're all consecutively located. Here, I don't really know where this node could be, so I need to access the address of it. Okay, so now I'm sitting over here, and when do you think I should stop moving this current to current next? When do you reckon we should stop? Ah! I almost revealed the answer. I think I did reveal the answer. Sorry. How do you think we would stop? Because I've said a few times, how would we stop? We know that we've gotten to the end of the list if we've reached this null pointer. So how do you think we would? Yeah, okay, that's right. When current is not equal to null. Yeah, until null. Well done. Excellent. Okay, so we really want to be moving through the linked list whilst this current is not equal to null, okay? So whilst it's not equal to null, we can keep moving across and across and across and across. But once it is equal to null, so here I've moved across to null, I want to exit outside of this loop. Because if we remember what happens when we try to dereference a null pointer, and this is where you will find the full, scorned null pointer being accessed to dereference, that's when you'll find the full sort of glory of it. It's not going to be very pretty. So you don't want to be accessing a null pointer, but you're going to see a few of those mistakes when you start playing with linked lists. Okay, so now my current is here, and that means I've kind of traveled all through this linked list, and I've been to every single node, okay? So the only way that we can make our way through the linked list is just like a scavenger hunt. We have to follow the links from node to node, okay? And we can't skip nodes. We only go from one to the next, to the next, to the next, to the next, okay? Now someone said, why are we making a list anyway? Is it for security? A list, it depends, okay? A list is one more data structure that is available to you. You have an array, you have a linked list. As you go on in computing, you learn a few more data structures that are available to you. And some problems lend themselves really well to be creating a linked list. And usually that type of problem has, something where you do not know how many items you will need. So you will use a linked list because you can dynamically create some memory to store these items in it, as opposed to guessing the number of things that you need. Okay, so we have to know where to start. So we need to know the head of the list. And when we reach the null pointer, it means that we have come to the end of the list. Okay. So let's do some code. Let's try and go through the code that we had. Maybe, Tom, could you please run a poll for us to see where we're at, if we're ready to go to some code? How does everyone feel about, moving the kind of the logic of moving through a list? And someone's asked, why is the address 0xff0? Shouldn't it just be the address of the following node? Where? The address where? Ah, okay. This is called bad copying and paste. Yes. Oh my gosh, apologies. Absolutely. This is bad copying and paste on my behalf. That should be 0xA44, and this one should be 0xFF0. Yeah. Correct. Yes. Good pickup. I will change it. Okay, I'll let a few more people vote, and then we're gonna... and then we'll write some code. This linked list, I mean, it's just a list. I haven't made it. Right now, we can only make it from tail to head, but we're about to learn how to put something at the tail of things. Can a linked list store more than one variable? Indeed, it can, because you have a struct, right? And we decide that the struct has an int data, but I can have an int data, I can have a char, I can have a string in there, I can have whatever I want in there. What defines it as a node and a linked list is the fact that it has a pointer in the struct to the next node. And that's what makes it a linked list, the fact that I can link them up. But inside that struct, absolutely, I can have more than one variable going. And so that's another really useful thing about linked lists. In an array, you only have, well, you could have an array of structs, I guess. Yeah, I'm going to cancel that thought. Yeah, so we're going to add, okay, let's do some code. Okay, I think people are sort of kind of almost getting it. How can we get user input as the data? You can scan it into the linked list, and then we can sort of move on. So the usual ways, really. I've just realized that I've stuffed this up. Not stuffed it up, but I created weird size windows. Apologies. And just mess here. Okay. That's not what I meant to do. Okay, let's write some code. And we'll talk more about what we did on Tuesday, which is insert at the head of the list with all those lovely diagrams that we did. Oh my gosh. Oh, Friday afternoons. Okay, here we go. All right, going back to our file, the same one that we used on Tuesday as well. Okay, so let's do that. Okay, so here we have our struct node. Okay, you'll notice I've also used a hash include standard library.h. The reason I use that is because that's where I get malloc from, so I can make new nodes, I can create nodes. Okay, then I make a node, and the node has an int data, and also it has the next address, so we've called it next address. Okay. And now we've created some nodes, we've added some nodes. So this is going to be a 531 list as opposed to a 135, but it doesn't matter. So now let's do a printing the list, okay? Okay, let's do a function to print the list. Okay, what do we think will be the output of this function? And what do we think will be the input of this function? If I want to traverse the list and I want to print out all the nodes, what do we think? What do we reckon? What do we reckon will be output, and what do we reckon will be input? Yeah, well done. Input is the head pointer, absolutely, because we want to show this function where to start. Head of the list. Excellent. And then what do you think is the output if we're printing out all the different nodes? Yeah, output will be the data onto the screen. Will we return anything to our main function? Yeah, that's it. It's just that. Well done. Well done. So, yeah. So it's going to be a void because we're just printing stuff out. Okay, excellent. Let's do it. Okay, so the function is void. Yeah. And what should we call the function which prints out the list? Oh, I don't know. Let's call it print list. I'm good at these. Oh, I should stop myself. Okay, and we're giving it the head of the list. So what are we giving it? We're giving it a pointer. Oh my gosh, I'm so blurry. This is terrible. We're giving it a pointer to the first node. Okay, so what I'm giving it is a pointer to the first node. So a struct node pointer. So this means I'm giving it a pointer to the first node. Okay. Oh, people are saying printer. Why not? We could do printer. Oh, well, why not? Fine. Printer it is. I can't look. Yeah, sorry. There we go. No. There we go. No. It's focusing on my fingers, but not on my, I think it hates my jumper. It hates my jumper. Oh my God. Oh, just Friday afternoon giggles here. Okay, so we're giving it the head of the list, and the head of the list is a pointer to the first node. Okay, so now we're going to do our beautiful thing where we're going to set the current. I'm going to have a new variable, and it's going to be current, and it's going to be set to the head of the list. Okay, so I'm going to have a struct node pointer, and I'm going to call it current. And I'm going to set it to the head of the list. Okay, so what that means is that if I have a pen in my hand, it's just not, things are just not happening today. Here we go. So if I have 3 nodes, this has 1, this has 2, this has 3, and they're kind of going like this. So this is my next address. This is my next address. This is my next will be null here. So what I've just done is that this was the head. This is also now the current. That's what I've done with that piece of code. So I've basically said my head is now equal to the current. Okay, so great. Now I'm just going to pulse through and traverse it nicely to get every single node and print it out. Okay, we've already talked about it in the chat before. We're going to have a while loop to visit each node, okay? And my while loop is going to search for my current not equals to null, okay? Because what that means is I'm now looking until I get to the very end. So I'm basically going to move across until I get down to here. So I want that current to keep moving until I equals to null. So whilst current is not equals to null, what I'm going to do is I'm going to print out the data stored in each node. So I'm going to print f, okay, and I'm going to print f a %d. I'm going to do a new line so we can see how it moves across, okay. And then what do you think I will be accessing, okay, when I want to print out the data inside my current node? So what will it be? How will I access this over here? Yeah, well done. Current data. Excellent. Okay, so I'm going to say current stab data. Okay, I'm going to print that out, and now I want to move the current across to the next one. So now I want to increment my current. So I want to move the current from here. I want to move it over to the next node. So how will I move it across? Who remembers what was my movement to move it across? Jeffrey, you ask a very good question, and we are going to have a situation where we're going to do that. So hold that thought. We're going to talk about it in like half an hour. Yep. And then we move it across by saying, okay, update my current to be current next. Okay. So update it to go to the next. So what that means is if I go current next, I'm going to access it and go move over to this one. So current is equal to current next is going to allow me to hop over to the next node. Okay. Excellent. And that's really all I need to do, isn't it? Okay. So that's really my whole function over here that will print out the whole list. Okay. Should we try it out? Let's try it out. Let's try and run it. This is going to be not pretty. I'm going to have to erase this because otherwise you won't see my terminal output. Okay, let's see what we've got. You know what I forgot to do? Who knows what I forgot to do? I forgot to do something. Who knows what I forgot to do? Yes, well done. I forgot to prototype anything. Very good. I am in the way. Thank you. Okay, prototype 1, and let's do the second one. And also I haven't called my printer function anywhere either. So I've written it, but I haven't used it. So we'll do that as well. Okay, so I've got prototype of that, and let's do prototype of my printer function. Excellent. It's always the prototype. This is my constant problem. So now in my main function, I'm going to call the printer function, and I'm going to give it the head of the list. And the head of the list is inside this head pointer here, because that's what we've said here. We've called it head pointer. Oh, yes. And someone has, yes, it should be next address. Yes, because we renamed it. Yes, this should be next address. Well done. Good spotting, because we've changed it. Yep. Excellent, excellent, excellent. My goodness. Let's try it again. Beautiful. Okay, now let's run it. And it's printed out our list for us. 5, 3, 1. Okay, well done. Okay, so how is everyone feeling about printing a list out? How is everyone feeling about the code to print it out? Okay, so now I think we're also ready to insert at the tail. What do we think? A little confused? A few people are still a little confused. Okay. Okay. Let's go over it in the context of inserting something. Okay. Let's go over this code. I'll draw it out again. And then we can talk about it in the context of actually, yeah. Okay. All right. So we had built up a list with, why is it in yellow? Who made it yellow? Tom. These fingers are not, I've got very chunky fingers and they're just not made for, there we go. I'm back. Okay, so let's say, oh, people are feeling linked. How exciting. Okay, so we've got a list which is 5, 3, 1. Okay, and then we've got next address pointing to here, next address here pointing to this one, and this one is heading out to null. Okay, and then this is also called the head pointer in our code. Okay, so when we did this bit over here, what we did is we said this is equal to current. Okay, so I did that on line 54. I set my current node to the head of the list. Okay, and then whilst current is not equal to null, so that means whilst current is anywhere but here down at the end of the list, keep doing whatever's inside that while loop. What that means is when you come out of this while loop, the current is going to be equal to null. Okay, and we're going to use this in a few cases. Okay, so now let's say I want to insert at the tail of the list. Okay, so let's say I want to insert, I don't know, the number 10. Okay, and I want to insert it at the end of the list. What do you think I need to do to insert something at the end of the list as opposed to the start of the list? What do we reckon? How will I get to the place where I want to put it into? So it's using that same sort of principle as you print. How do you get to the end of the list? Change the point of the current last node to the new last node. Yep, go to the last. Yep. No, don't go. No. We won't be able to go backwards. We can only ever go forwards in a singular list. So what we can do is I'm going to, if I know that I have to insert at the end, okay, what I'm going to do is I'm going to move myself here. Is this the end of the list? No. I'm going to move myself here. Is this the last node in the list? Yes, it is, which means I'm going to insert after the last node in the list. And I think Jeffrey before this mentioned, okay, why aren't we doing when current next is not equal to null? Okay, and it's because if I do, okay, so there's always two options for you, and you really need to draw it out to see where you need to stop. Do I need to stop at the last node, or do I need to go past the last node and include it and stop after that? Okay. Now, if I say whilst current is not equal to null, so if I go the same way and I say while current is not equal to null, you know, keep moving through this list. What that means, oh my gosh, that's terrible writing. Apologies. And it's not very thick. Sorry. Let me make it thicker so you can see what I'm doing. Okay, there we go. Okay, so whilst current, if I do whilst current is not equal to null, what that means is when I exit out of the while loop, my current is going to be equal to null, okay? So what that means is I am standing over here. So if I try and insert a node, now in here, I can't because I don't know where this node is. Okay, I can't connect this node to the next node now because I've gone past it. And now I'm just at a null. I'm at nothing in particular. So when I'm inserting at the end of the list, what I want to be doing is I don't want to go past it. I want to stop at the last node, which means a few people are popping in the chat exactly when I want to have when I get to current next is equal to null. So when my current, I've got to stand over here, and when current next is null, so when this is null, I'm at the last node, okay? And that's when I want to create a new node. So for example, what I would be doing then is, if we go up a little bit, I don't know if we should do it as another function or if we should, we've already got a create node function, so maybe we'll do an insert at the end function. We're going to have a lot of linked list functions. Let's go with that. Okay, let's do this function. Function to insert a node at the end of the list. Okay, let's talk. What do you think is going to be the output, and what do you think is going to be the input of this function? Call it inserter. Okay. It's not, well, no, I can't call it that because I can insert in other places as well. This one is just at the end, but I could insert between any two nodes as well. Okay, input would be a pointer. What kind of pointer would be the input? What do I need to give it? You're right that it would be a pointer, a node. What would be the pointer? Well, it depends. You're right. It could be the address of the last node, absolutely. But I'm going to do my logic inside this function. So I'm going to make it the head of the list. Okay. So I'm going to make it the head of the list because that means I'll move through to the end and do it all in this function. And what will I return out? An output is the pointer to the new node or to the what? Yep. So you're right that it will also be a node, a pointer to a node, and we can see what it's going to be in a second. Okay, so it's going to be a struct node pointer. I'm going to say insert at the end, okay? I know just because this is going to be just at the end. And we're going to give this list the head of the list to work with. Okay. All right, you're going to get very good at this. This is going to be the next thing. So you can never pulse through the list until you have a current, okay? So I'm going to create a new pointer called current, and I'm going to set it to the head of the list. What that means is I'm now not going to be, I'm not going to be changing the head pointer. The head is going to stay the same in my function, and that's what I want. I want the head to stay the same because I'm really going to return the new head of the list back to my function, okay? Because then it's just going to insert the node in and I'm going to return the head of the list where it starts. Okay, so now I need to make my way through that list to get to the last node before I start to create a node and insert it. So let's do that again. So we've got our while loop. We had decided that this time we're going to go current next address is not equal to null, which means that when we exit out of this while loop, it's going to be current next is going to be null, which means I'm going to be over here. Okay, I'm going to be at this last node over here when I exit out of the while loop. So all I want to be doing in my while loop, I'm not actually doing anything. All I'm doing is just moving through the list, which means that all I'm doing is just saying current is equal to current next. So keep moving until I get to that last node. And then when I exit out of this loop, so at this point, your current next is going to be equal to null. And that means you are sitting on the last node. Okay, so that means that this is the time that I now have to create a node, okay, and insert it in. Okay, so let's think about it. If I create a node, well, I already have a function to create a node. So I'm just going to call my create node function. Okay. So what I'm going to do is I'm just going to call this create node function. And I want it to create, I don't know, the value 10. And I'm going to give it null to create with. Okay. So I've asked it to create this lovely function. So what it's done is it's going to return the new node. I currently don't have anywhere to store this new node. So okay, so I've got a node and now I want to link this node to the last node. So what do you think I'll do? What do you reckon I'll do? So this piece of code here, let me draw it up. This piece of code here now on line 61, what it's going to do is it's going to make the call to the function create node with 10 and null. And what it's going to do is it's going to go to this function here, okay? And it's going to say, okay, struct node, new node, malloc size of struct node. So what that will do is it will create the node for me with enough stuff here to store it. And the address is going to be stored inside the variable new node. I'm then going to give the new node some data and I'm going to give it 10, which means I'm going to address it up with a 10 in here. And the next address is going to be the address that I gave it. So it's going to be the null. So I'm going to address it up with a null in here. And then I'm going to return that new node. So I'm going to bring that new node, this lovely new node that I've just created, I'm going to give it back to where I called it from. So it's going to come back here. So that means that the address of the new node is now sitting in here as well. So this is my new node. And what I want to do now is instead of this being null here, which means I'm at the end of the list, I want to direct it to this one over here, okay? So I want to break that, direct it over here, and then this one is the one that's going to be to null. So how do you think I direct this last node over here, which is located, my current next is equal to null right now. How do you think I direct this to the new node instead? What do we think? Yep. Yep. I'll just wait for a few more. Yep. Okay. Excellent. So you want almost. Sam's got it. Yep. So I'm saying that this current next in here, so what I want to do is the current next, so the address that is stored in over here is now going to be this address instead of null. So it's now going to be the address that's inside my new node. And because I created my new node with a null, I don't really need to do anything because it's already going to a null, so nothing else needs to happen. So what this will do now is it will insert a node at the end of the list, okay? And then I need to return something. So what do we think I need to return now? What will I return to the main function? What do we reckon? And we'll go through the code again. Don't worry. We'll go through the code together with the drawings again. So don't worry. Yeah, well done. Okay, so what do we reckon? So someone says new node. So if you're returning new node, what you've returned is you've just returned this node here, okay? You've just returned this node here, which means you returned the last node of the list. What do you reckon you need to return to be able to access the list? Yeah, the head of the list. Yeah. Yes, it does. Thank you, Neil. Yeah. Okay, so I'm returning the head of the list because otherwise, if you return new node, you have only made the address of this node available, which means I don't know where to start this new list. I have no idea. And if I have returned, if I was inserting somewhere else, I've lost where the head is, right? So what I want to return is I want to return the head of the list. So I want to return that head. Okay, so let's have a look. And now let's insert something here at the end. So I'm going to insert at the end. So I'm going to call the function insert at the end, and I'm going to give it the head pointer, and then I'm going to print out the list. Okay, actually, I forgot already to do a prototype, so let me do that. And we're going to see how that works. Okay, I'm also going to erase all of this stuff whilst we do this, and then we'll redo it and we'll go through it bit by bit again. Okay, let's compile. Let's run it. And fantastic, 10 is inserted at the end of my list. Yeah. So this is kind of what we wanted. Okay, poll please. Thank you, Tommy. Appreciate it. How is everyone feeling while Tom is getting the poll going? How do we feel about inserting at the end? And Jeffrey said you'd always return the head. Not necessarily. Depends what your function is doing. But a lot of the time you will return the head of the list. But not necessarily always. Not good. Okay. Oh, breaking my heart. If you can give me an indication, if you're feeling, a bit iffy about it, if you can give me a little indication of what it is that's throwing you off, that would be fantastic, because then I can zero in on that part as opposed to kind of, just drawing the same thing again. Okay, so the function struct node create node returns a pointer to a struct of type node. Yeah, so it returns the address of this node that you've created. That's what it does. It returns an address of the node that you created. Look, I want you to, it's not just to you. Look, linked lists, if you haven't seen them before as well, it's a complex data structure. Okay. It's not easy. Okay. And we're not just learning about the data structure itself. We're also throwing some C syntax at you as well, at the same time. So this is the way that we make a linked list happen in C. But, when you go on to do other languages, it's not necessarily always the same. Okay. So this is really complex stuff. It's not easy. So please don't be alarmed if you're just sort of sitting there going, what is she talking about? I still don't really understand it. Okay. It takes time to process it and to understand what's going on. Once you start practicing and once you start doing exercises with linked lists, you are going to really be able to grasp it a lot better. And definitely draw the diagrams, because often, you don't see what needs to happen until you can draw it and see, okay, it makes sense for me to stop at the last node or the second last node. Then which connection do I need to change? And it allows you to really see, to almost write the code itself. Okay. So I see a few people have asked, why do we return the head? Okay, I'm going to answer that one question first, and then I can see Neil's asking, does the new node point to null? I'll answer that in a second as well. Okay, so why do I return the head at the end of the insert function? And the reason for that is, if I return, so let's say I'm just going to go to any diagram here. Okay, let's say that this was the node that I've inserted over here. Okay. Now, if I just return the address of this node, I might not know where the start of the list is. So in my case, I haven't changed anything at the head of the list, so it's not a problem. But if I was inserting at the head of the list, I would be changing the head of the list. So I need to know where to start this linked list, okay? So the head, in my case, you are completely correct. The head is still pointing to the first node. I haven't changed it. But it's good practice to return, to get into the habit of sort of returning the head, because that's usually what you need to start traversing through a list, or that's what you need to access the list. So we will often return the head of the list in case it has changed. And in some situations, right now this function is very specific. We are, inserting at the end, so the head is not going to change. But perhaps your function will be just an insert function, and then you have options. You could either insert at the head, at the tail, or somewhere in between. So that means that your head might change, which is why you would return the head. And yeah, in this program, hypothetically, I don't actually have to return anything, okay? I don't really have to, because the head hasn't changed. I'm playing around with memory addresses. They're still there. Nothing has happened. So I don't specifically have to return anything. That's right. Yeah. So it's really, in this case, it's returning the head to get into the good habit of, because we're writing very specific, very small functions right now. Usually you just have a function to insert, and then you've got 3 places where you could do it. Okay, so I think it's a good time to take a little break. And what we'll do is we'll take a 5-minute break. I'll let it sink in, and then we're going to go crazy, and we're going to insert it, in the middle of 2 nodes. Okay, why not? Why not? I feel like we're there. All right, so let's take a little break, and then we will come back. Hello, everyone. Okay, back. We're back. I see someone's got some secret marks up there. Okay, there is, so this riddle in particular, I love this riddle because it came out a few years ago and it like stumped everyone because it was like, it's a whole vibe. Anyway, there's like a cool YouTube video that solves it. It's like a mathematical proof. I'll share that with you because I lost the link for it because I accidentally PDF'd my notes. Okay, let's get back to linked lists. I didn't have to sing that. I'm sorry in advance. Yeah, you definitely shouldn't be using global arrays. My goodness. Yeah. Okay, let's do it. So can I go over the current code once more? Absolutely, I can. Indeed. And I'm going to draw a diagram as well with it. So what I'll do is I'm actually going to expand all of this. And I'm going to expand this. We're going to draw a diagram and then we're going to talk about, I'm going to go all the way, okay? All the way from main, we're going to draw up this code so that you can see what this code is doing, okay? Okay. First, that was not a good place to start. Hang on. Okay, first one, we remember that we have a node. Our node is made up of some data and it's made up of the next address. So a pointer to the next address. So let's go inside our main. And the first thing we do is we say, I want a pointer to a node. So a struct node star. So pointer to a node, and I'm going to call it head pointer. Now here I'm saying the head pointer, so this variable that stores a memory address, is going to be equal to whatever happens here. Create node 1 null. So I'm going to go down to here and I'm going to create this node. So I've given it a 1 and a null to go with. So 1 and null. So what that means I'll do is I'll do next line 42, struct node, new node, malloc, size of struct node. What that does is that creates the space for me to be able to store that node. So I've created this node and the next thing I do is I access the data part of it and I give it the number that I've sent it, so number 1. And then I access on line 46 the next address and then I give it null. Okay, actually Neil asked before the break, why did the node have a null? I find that it's easiest to create, when you create the node, to just give it a null to start with, and then you can hook it in wherever it needs to go, and you can change that as you go. So, I mean, there are, you know, some people do different things, but it's, you know, it's often very good to be able to initialize everything, and so that's why I don't know where this node is going to go yet. So at this point, I set it to null as the way to go. Okay. So I have this single lonesome node and I know that this is the address of it is stored inside the new node variable. I now return the new node over here, okay, and it's also the head pointer. So that's now head pointer. Okay, excellent. So now I go over here, okay, and I say, okay, the head pointer is now, I'm going to create the next node and I'm going to have a 3 and what is currently the head pointer. Okay, great. So I'm going to create that node, number 3. So again, I'm going to get some, you know, data for it, malloc some space. That's on line 42. So this is now new node, this empty node. And then here it says on line 45, new node is the data. So the data was number 3. So I'm going to do that. And then the new node next address, whatever was given to me in the address was given of the head pointer, okay? Which means that this over here is going to be pointing to wherever the head pointer is. It's over here now, so that means it's going to go this way. And that means that I'm now moving in this direction, okay? Okay, great. Then I'll return the new node over here. So this is now my head pointer. Okay, so now I'm going to go down to here and I'm going to do it again, this time 5 and a head pointer. Okay, so I've got 5 and a head pointer, excellent. So what I'll do is I'll create the node, which is where I malloc some space on line 42, and I'm going to, on line 45, give it some data, which is the number 5, And on line 46, I'm going to give it the next address. So whatever goes in here, and it's going to be the head pointer. Okay. The head pointer is now over here, which means that I'm going to be pointing it this way. Okay. So that means the address is going to be off here. And then I'm going to return that node back inside here and make it the head pointer. So that means that this is now the head pointer. Okay, now I go over here and I call this function here that says insert at the end of my head pointer. So what I'm sending it is the address of this node over here. I'm sending it to my insert end function. Okay, great. Let's go down to the, not what I meant to do, apologies. Okay, so I'm going down to my insert at the end function, and let's see what this function does for us. Okay, so I've said insert end and I've given it the head of the list. Okay, first thing I do is I say struct node current is equal to head. So I've given it this head pointer, and now I said please create another variable called current that is a pointer to a node. Okay, so that's head pointer and that's also the current node. And now I'm saying whilst current next address, so whilst whatever's in here in this next address is not equal to null, do current is equal to current next. So first node, I'm going to check, is my current next equal to null? No, it's not. So I'm going to go inside the while loop, okay? And that means I'm going to say current is equal to current next address. So I'm going to access this and move the current down. So the current is now going to move down to here. Great, I'm going to go inside the while loop again and say, okay, is current next equal to null? No, it's not, because there is a pointer to the next node, okay? So then I'm going to go inside the while loop and I'm going to move it along one. So I'm going to say current is now over here. I'm going to go check again inside the while loop. Is current next address, is this equal to null? Yes, it is. That means I'm not going to go inside the while loop, and I'm just going to exit out to line 63. Okay, then on line 63, I say, can you please create a new node for me with 10 and null in it? So I'm going to go to my create node code, and what it's going to do is it's going to make something called new node, and inside it is going to be a 10 and a null. Excellent. And now on line 64 is where the magic happens. That's where I'm actually inserting it in. So I'm going to say current next address. So the current is over here. I'm going to go into my next address. Currently it says null, but I want to set it to new node. So I'm setting it to something called new node. That means that this link is now broken, and what that is doing is pointing to this new node. And then I'm going to return the head of the list. So I'm returning this head pointer back to my main so that I can traverse through this list again if I want to print it. Okay, how's that? How is that? How is that chunk of code? Because we're about to insert anyway. We're about to insert between two nodes. Yep. If you printed current, what would you get? You'd get nothing, because current is, you need to access, current is a pointer to this whole node. So what part of that node do you want? Do you want to see the data, or do you want to see the address? Because there's two parts inside this node, okay? So if you printed current data, you'd get a 1. If you printed current next address, you'd get the address of the new node. Okay, let's try and talk about inserting. All concepts linked. I know it's going to be all the feels of your next few years at uni. Everything links up and you just think, why am I learning all this? But it all comes together. Okay, let's have a look. All right. New linked list. Let's say I have a linked list. Okay. Okay, whilst I'm doing this, can you please tell me what number we should insert? $88. Okay, let's insert 88. Where would we like to insert it? Where should we insert it? Let's insert between two nodes. Okay, so now we know how to insert at the head. We've talked about that. We know how to insert at the tail. Let's do, oh, well, someone actually 4 between a 3. Oh, the meaning of life number. No, it's true. 42. I feel like we have to insert 42. And let's insert it between a 3 and a 5. Okay, let's say we want to insert, we want to insert between a 3 and a 5. And we want to insert a 42. Okay, so what's going to happen? What do you think we need to do? What do you reckon would be the logic? What would we look for before we stop? I want to be able to stop, actually for this example, no, for this example it's better for, it should have been better to do a 4. It will be better to do a 4 for this example, okay? Then we can go crazy and so let's say we know that these numbers are kind of like in order, and we're going to insert a 4 between a 3 and a 5. So how can I stop at 3? Okay, stop at 3, but before I move past 5. How do I do that? What do we think will be the logic of that? What do we reckon? Yeah, look for the node before the spot you want to insert. Yes. I agree. So I want to look for a node, okay? I want to look for a node that's more than 3, but less than 5, yeah? And then I'll insert the 4 in because it's going to be, so I want to be less than 3, no, more than 3, but less than 5. So I want to be looking for a node. So, and remember that inside here, how do I check inside here? If I have a current, again, I stab the data. So I want to access the data part of that. Excellent, an if condition. So I want to have my current data be be more. You see, it's like 7 weeks. How old am I? Let's not even talk about it. And still less than, more than, it just drives me insane. So we're looking for something that is more than 3 and less than 5. Okay? Took me too long to think of those things. How is that if condition? What do you think? So the way we would do it is we'd again start at the head of the list, okay? And we pulse through until we find what we want to find. So I'll start my current here at the head, okay? Is this less than 3? Oh my God. Is this more than 3? Oh my God. I shouldn't ever have conditions that have less than or more than. Okay. Is this more than 3? It is. No, it's not. Oh my God. 1 is definitely not more than 3. So let's move on to one more. Okay. Okay, someone said, why is it less than 5? The reason I want it to be less than or equal to 5 is because then there is a lot of things that are more than 3, right? 5 is more than 3, 7's more than 3, because I'd keep going. But I want to insert it between the 3 and the 5. So that's why I want it to be more than this node, but less than the other node. It's an example to show you how can insert between the two nodes. You would have much better conditions that you would work with usually. Okay, so that's why I'm doing it. So am I more than 3 here? So when the current has moved down to here, is this more than 3 or equal to 3? Yes, it is. And is current, oh, I've made a mistake here. I've made a mistake for this one. That's wrong. See how if you draw it, then you can see that it's all a bit of a disaster. because I'm checking if current data. So I'm still checking that 3. Is that less than 5? Yes, it is. Doesn't make any sense. So this condition here is wrong. What should I be checking? Because I really want to check this node over here for my insertion point, because I'm between two things. Yes, well done. I really want to be checking current. And look at this. We haven't seen this before. I want to be going current next, which will take me over here. And then I'm going to access the data. So I can have as many stabs as I want, okay? And sometimes you'll get current, next, 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 lots of stabs. So that's why I was saying, you know, if you have the brackets, it's going to get very confusing. So if I do current next data and the current is standing over here, what that's doing, when I do the first stab, current next, that's going to move me over to here. And the data here is this 5, okay? So then I can check whether that's this thing here is less than or equal to 5. What's people saying oh no for? That I can do many, many stabs? Just wait till you see, yeah. I can just traverse the whole list by saying current, next, next, next. Don't ever do that. Unless you're checking for conditions. Yeah. How are we feeling? Just like average? Yeah. I mean, it's not like, yeah. The reason current less than equal to 5 doesn't work again is because current is over here. So when I go into current data, that's this element over here, which I'm checking in this condition. But what I want to check is that this is more than 3 and the next node is less than 5 to find this in-between point in which to insert. So to access the next node after my current, I do this bit here first, which moves me onto the next node, and then I stab into the data point. Yeah, and look, these are just made up numbers, okay? I'm just showing, it's just it's like, it's not a, you know, it's oh, a few people want to go home. Surely most of you are at home watching this. But I appreciate you tuning in on a Friday afternoon. If only to see that the camera hates my jumper. So the condition would never be, have I got the wrong, is it less than, more than? No, I feel like that's the right condition. Has to be greater than 3, but less than 5. Yeah, that's right, isn't it? Making me doubt myself. Yeah, that's right, as Tammy says. If you've got like quite a few next, you need to stop and think about what you're doing. You need to think about your choices in life. Why do I have to go less or equal? I don't have to. I don't have to. I don't have to have the equal sign. It's only because it's just, I've chose this. We don't have to. It can just be less than 5. Yeah, it doesn't have to. Okay, this is, okay. Oh, Bill, I love it. What if the list has duplicate nodes in it? Then how would you know where to insert? Usually you'd have better conditionals. Like I've just made up that we need to insert a 4 between a 3 and a 5, and now my conditional is fitting into my question, as opposed to I'm solving a question and I'm going to, you know, change it up kind of thing. Okay, Neil, excellent. Couldn't we go, whilst current next data is not equal to 5, you could, and then what? And then you would insert at the current. You could do that. Why not? You could do that. Yeah, you absolutely could. And remember what I said, it's not in computing, you're going to have more than one solution to things. It's not always going to be one way. That's it. Everything is black and white. It's not so simple. There's 3 or 4, sometimes more ways to solve. In fact, each of these questions I can solve with an array or with a linked list. It's just that one solution might be more efficient than another. One might be, 10,000 lines of code when I could have done it with 500 lines of code. Oh, people are doing great thinking in there. Yes. I knew I had equals for a reason. That's correct. Yes, well done. You really can't. You have to have the equal signs. You're right. How's that feeling? So should we try and link it up? Should we try and do it in code to link it up? How are we feeling about that? A lot of people want to go home. Don't worry, 27 minutes to go, and then you're free to do Friday night, and then you can, hey, oh, my feelings are hurt. I thought that this is what, in 3 weeks' time, no more Friday afternoon lectures. You'll be devastated. You won't know what to do with yourselves. Okay, let's try and write some code for it. Okay. To our lecture after this. Oh my goodness. Oh, someone's watching this lecture with a Friday bevy. Why not? Okay, let's do it. Let's write some code. Let's insert in the middle. Shoots after this. My gosh, who made these timetables? This is terrible. I hope that this is your first time out of school and you will never make the mistake of doing Friday afternoon classes again. You learn quick smart. No 9 a.m. classes. No late Friday afternoon classes. Okay, let's do it. Okay, let's insert in between. What are we calling it? And then we're going to talk about all the things that can go wrong. So let's just do one that's also very specific. And then next week we're going to talk about, where the issues are and stuff, like where the problems are, tricky edge conditions, and so on and so forth. We'll do that next week. Okay, function to insert between two nodes off the list. Okay, inputs, outputs, please. What do you reckon the inputs and the outputs are going to be? Yeah, you can. So you can, I created a complex condition. I agree. You can do a few things. As Neil had said before, you can keep going whilst it's not equal to 5 and insert then. I like that. Or you can check if it's equal to 5, then insert before it. Absolutely, you can. Yeah. Yeah, input is the head. I agree. And output, what's going to be my output? And output is the head as well. Why not? Yeah. And again, in this case, we don't, because again, we're writing a very specific function. Next week, we're going to see why you need to return the head, because we're going to just do an insert function and insert it anywhere kind of thing. But let's get into the habit of returning the head of the list, because that's a good way to, kind of start with that. All right, so I'm going to return the head. So I'm going to return a pointer to a struct node variable, struct node pointer, and insert between is going to be the calling of this function. And I'm going to give it what am I going to give it? I'm giving it the head as well. Okay. Oh, that's a very good thinking. Yes, Jeffrey. I would need to specify where I need to insert it. Otherwise, what am I doing? You're right. Yes, you see, this is what happens when you make up examples and you forget that you actually have to have some context around it. Okay, so let's say our list, we should need it. Okay, how should we do it? Insert between, and we're going to give it the head of the list, but also we should tell it where to insert it. What are we going to tell it? What do you reckon we're going to tell it? How should we specify where to insert it? Yep. So we could do it, between which two numbers? Yep, 3 or 5, I agree. Okay, let's try it like that. Okay, so what we're giving it is we're giving it 2 data points, okay, and then we're just giving it the head of the list. So we're saying insert between 3 and 5, and here is the list that you want to insert. Oh, hang on, but we need to tell it what to insert as well. Oh, this is getting to be a very complex example now. I wish to take it back and do a simpler example than what I've just created in this monstrosity of a question. Let me have a quick think of how to do it better. Can someone please play some elevator music? Elevator music, my thinking music. Brains. Fried. Oh, you know what? Why don't we just do 4 arguments? Who cares? It's a Friday afternoon. Let's live a little. Okay, I'm going to insert a 4 between a 3 and a 5. This is a terrible function. I hate it. No. Two seconds. Really need that elevator music. Feeling very awkward here. Okay, no, I've got a better idea. Here, I've got a better idea. Let's do, okay, insert in the middle of 2 numbers, okay? Because then if I'm inserting a 4, then I know that I have to insert it between a 3 and a 5. What do we think of that? Thoughts? Yeah, someone's already said that up there. My goodness, I didn't even see that. Let's do insert in the middle. Yeah. I'm going to do insert in the middle, and we're going to give it the head of the list, and we're also give it the data that we're going to insert. So here I'm going to call insert middle, and instead of this monstrosity, I'm just going to give it the head of the list, and I'm going to give it what I want to insert in. So the number 4 I want to insert in. Okay, let's do it. It's like every time I start coding, there's like a little soundtrack that plays in my head. I shouldn't have told anyone that. I'll let you guess what songs are in there. Sometimes when things compile, it's Eye of the Tiger. Okay, so I'm going to get a current node, and I'm going to set it to the head. Yep. So that means I can now keep track of where I am in a linked list. Okay, excellent. So that's a useful thing. That's a useful thing to do. Okay, great. So now what do I want to do? I know that I want to have a node with this data on it. So I can prepare that node, okay? So I can prepare it, I can create the node, and then just leave it kind of empty and hanging, okay? So let's do that. And I know that I can create it because we already have been doing the creation of the node. So I'm going to create this new node by calling my create node function. And I'm going to pass it that data point and a null to create the node. So this data point is now going to be passed to my create node function. And then I'm going to give it a null. So I'm going to create a node. It's going to have the 4, and then it's going to have the null. And it's just going to be sitting empty. It's not going to be connected into anything at all. Okay, great. I now have a node. So now what do I want to do? I want to traverse through my list to find where on earth to insert it. Okay, So we had a few different ways to do it. Okay. Should we do it? We can do it with an if statement, like an if condition, or we can do it inside our while condition. So we can do a whole bunch of things here. So which way would you like to do it? And okay, this is clearly now sitting inside my head, so it's making sense to me. So you will have to tell me if it doesn't make sense to you. Okay, I'm going to do a while loop, okay? And then, yeah, let's do a while and an if. So whilst current is not equal to null, which is the way that I'm going to move through the list, okay? Moving to the null ensures that I go through the whole list. So I don't stop at the last element, but I go past it. So that means I can cover the whole list when I do that. Okay, now I want to check stuff. Okay, I want to check, as I'm moving through the list, I want to check that my current, I always do that. I always press shift too early and then I get this weird arrow that's like lopsided. Okay, so then I'm going to say if current data, I'm obsessed with that, is less than the data that was given to me. Another one is more. Yeah, I'm going to do that because I'm inserting in between them. Okay, and you tell me if it doesn't make any sense, okay? So if current data is less than or equal to data, spelling, and my current next data is going to be greater than or equal to data. Does that make sense? If current data, so if I'm inserting a 4, is 4 less. Okay, we're going to see if it makes sense after we run it. Anytime it has a less than or equal, then it's not gonna make sense. No, someone's saying no, it doesn't make sense. Should they be the opposite way around? Is 3 less than or equal to 4? And is 5 here? Okay, fine. Let's do it. So this would be 3, for example. And this data is 4. Is 3 less than or equal to 4? Yes, it is. And is 5 greater than or equal to 4? Yes, it is. So it's like I found like a place in the middle. So I'm just inserting in between two numerical values, basically. So I'm inserting it as close as possible between them. If I wanted to insert 420, it's not going to work because I'm not writing this function to work for that, if that makes sense. I'm only writing it to insert in the middle of two nodes, like numerically. You are completely right, it wouldn't work for 420. It would try and insert it at the end and it would have some problems doing that. So this function is really just to show you how to hook up two nodes in the middle of two nodes, if that makes sense. Okay, so that means that I have this node here, for example, what it would look like, this node here, and this is the current node. It's going to have some value here, and it's going to be over here. So if this is current, then this one is the current next, okay? And I have my new node sitting out here that I want to link in there. Okay, so this is my new node, and I want to link it into here. So how will I link? What will I link in? So I really want to go from my current. So from the current, instead of this, I want to actually go in here. And from here, I want to go to this one. Does that seem all right to you if I want to link it in the middle of two nodes? Does that make sense? No one's replying. I'm feeling sad. Does it make sense? Yeah? Okay. All right. So how would we do it? What do we reckon? So if that's equal, if that condition is true, I'm going to try and insert it. Okay. What happens if we do? Okay. What happens? And I'm just going to do it. I'm going to do it not quite correct to start with so that you can see perhaps that something doesn't make sense. So I want to say that my current next. No. How do you think I should go? What do you reckon? Okay, you're saying current next should be to the new node. So if I've stopped here, if I've stopped over here at my current, then what would be my connection? So I want my new node to be at the current next. I want my current next to be at the new node, yeah? So we're saying we want to say current next is going to be equal to, okay, let's try that out. If I say current next is equal to my new node, okay, excellent. So what I've done here is done this, okay. I've said that whatever's sitting inside my current next, so whatever's sitting in here, is now going to point to here. How do I, and that means I've broken this arrow. How will I now get to know what this address is? So think about it. No one else knows the new address, and I've just overwritten it. I've just written the new node address into my current. So what do you reckon we should have done first? What do we reckon? Can we see the situation? Yeah. So we want to be first doing the new node. Otherwise, we're going to lose the address of the next. So I could do a temp if I wanted, but what I would do is I would just assign the new node first. So my new node, I'm pointing at the screen, not that you can see. My new node over here, okay, I'm going to assign it first. Instead of this null, I'm going to point it to the current next. So I'm going to do that arrow first. Okay, so new node is going to be equal, new node next, stabby stab at next is going to be equal to my current next. Okay, excellent. And then I can overwrite the current next. And then the current next is going to be equal to the new node. Yeah? So then I've gone back to front and I've been able to save this situation of having it, okay? And now when I come out of whilst I'm still inside the while loop, I need to increment. So I'm going to say current is equal to current stab next. Because that will make sure that I can move through the different nodes. Yes, it is. Sorry, I keep forgetting. We changed it to next address. Yes, 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 you are correct. Okay, excellent. Very good. Okay, and then we've said that we're just going to return the head. How do I know which current next I'm talking about in any given situation? That is, what if I don't increment it? I'm going to get stuck in an infinite loop. Okay, how do I know? And this is why it's really useful to draw a diagram, because on your diagram, okay, without these arrows, I hate this thing. If I have something that looks like this, okay, I don't know, let's do one more, why not? Okay, let's say I have something like this, right? This list with 1, 2, 3 in it, okay? And if I say, okay, this is the head of the list, and that's also where I'm going to say my current is, I can straight away say if that's current, then this is current next here, okay? So that's how I keep track of where it is. And then when my current moves over by 1, so when the current moves over on the next loop, then the next one is going to be current next. So the way you name it is actually with the arrow. It actually becomes quite intuitive because it's the current and then the next one is the current next, okay? And so I can keep moving it onwards as well. So that's how I kind of know I can keep track of where I am at any given time, because I know that the current next is the following one. So when I created a new node, okay, so when I created my new node here, And I said, okay, I want to insert it in, and this is my new node. If this is my current and this is my current next, okay, that still stays as current and current next. So, but current next is this bit in here, okay? That's the address in there. It takes me to that one. So if I want to insert this one in here, if I override it first, whatever's sitting in here, then this becomes current next, okay? And that means I no longer know how to access this node. This node is now lost to me forever in memory, and it's gone, okay? I have no access to it. Okay, and then, yeah, so the loop will finish when you get to the end of the list. So when you're equal to null, when you're over here, that's when the loop will end. So when you come out over here, outside of the while loop, you're right at the very end. Current is equal to null when you come out. If we return head, where is this stored in the main function? I'm not sure I understand the question. So it depends what I'm doing with that head. I'm not storing it per se, because it's just my head of the list. It's in memory. I haven't killed any memory. I think that's what you're saying. So it's like persisting across. And so why do you state new node is equal to next address and current new node next address is equal to current next address? Does new node current next address? Oh, I see what you're saying. Yeah. Okay. The reason I said that is because new node, remember, it's a pointer to a struct. Okay? And there's two elements in here. There's new node data, which is this bit here. So this is my data point. And this is my next bit. So the reason I say new node next is because I want to change the address of the next thing to be this node. I don't want to change it. I can't really change. New node has the address of this whole node in it, okay, which is both the data point and the pointer to the next one. And all that I want to change is the pointer to the next one because I'm inserting it between two nodes. Yeah. Yeah, and that's right. Yeah, head is the pointer, yeah. Okay, how are you all feeling? Tommy, could you run a poll to finish us off before everyone brain explodes? My brain's exploding. How is everyone feeling? What's the feels for this Friday afternoon? Is anyone doing anything good on the weekend that's going to take their mind off linked lists? Yes, of course. There is a way to insert nodes. Yes, you can absolutely. It depends. Sometimes the condition will be, insert a node, at the third node, let's say. After the third node, then you want to insert it. Then you would just count the number of times you've moved over. And you could do it like that. So there's a lot of different ways you can insert nodes. The point of that example was to show you how to hook it up in between two nodes, really. So I wanted to show you when you need to change two next addresses. Oh my God, roller skating, that's fun. Purging your closet. Oh. Yeah. Yeah. This will be useful for your assignment. Dare I say it. Make a function to return my brain cells. Nope, they're all mine. I'm keeping them all for this weekend. I'm going to take over the world. Why is 4 pointed to 3? I mean, it's just because I wrote different numbers. If you were to have the same ones that I had before, it would be 1, 3, 5. But I just did a random example, really. So if we want to have similar to what I did before so that it's not confusing, it would be like that. There we go. Okay, so people are very keen on this assignment too. But do you prefer it released tomorrow or Sunday? Yeah, I'm inserting. tomorrow. Wow. Sunday. Oh my God. Someone wants it released. My God, lots of never. That wasn't an option, but I like it. I like it very much. When is it due? It is due on the last possible date. It is due. It's going to be due on the Friday of week 10. The last possible. Well, I felt like if we release it today, April Fool's Day, my goodness, that's a bit harsh. And also, you might think it's a joke. You know, we did have this idea to fool you with an assignment 1.5 for April Fools. And then I thought, my goodness, the cruelty of it all. The cruelty, the cruelty, the cruelty. Yeah, well, that's right. I don't want you to think the whole assignment's a joke. Oh, Saturday is pulling ahead by a few votes. I feel like I'm navigating a horse race. I don't know why I said it like that. Was it? I thought it was fun. Yeah. I also didn't want to release it until you had sort of enough information as well to cover you at least for the first bit of stage 1, right? I don't like it when you look at something and you think, I don't know how to do that. So which comedian thought of the secret mark thing? Well, it was better than assignment 1.5, I think. All right. We're going to finish up there. If you have any feedback, and the poll is still running. Oh, what's the secret mark? Go to the web page and then you might see what the secret mark is in the banner. So with your current knowledge, okay, with your current knowledge, you can get through stage 1. And maybe stage 2, depending how well, maybe a bit of stage 2, but you'll be able to do stage 1. I am. I'm picking out all of your brain cells. You are not safe. I'm going to take them all. All right, everyone. I hope you have a wonderful weekend. Oh, look, someone's Eden. You sound like my grandmother. Okay, so thank you all for attending on a Friday afternoon. Lovely to have you along for the linked list ride. Thank you for supplying your brain cells to me. I'll put them to good use, I promise. And I hope you have a wonderful weekend. It looks like Saturday is the winning date. So we will probably release on the Saturday, and I'll see you all for another exciting linked list adventure on Tuesday. Hope you have a wonderful weekend, and please, please, please sleep a lot on your last good sleep before assignment 2. Bye, everyone.